Hello everyone, welcome again to our math tutorial. A few weeks ago, we have already discussed the different triangle congruence postulates and theorems. Now for quarter 3, week 6 to 7, we will only focus on right triangle congruence theorem. Before we work on the theorems, let's have a short review on the different parts of a right triangle. A triangle is considered right if it has one angle which measures 90 degrees. The remaining two angles are acute angles which measures less than 90 degrees. The side opposite the right angle is called hypotenuse. That is the longest side of a right triangle. And the sides opposite the two acute angles are considered the legs. Let's work now on the different theorems of a right triangle. We have leg acute angle theorem or LA theorem. Second, leg-leg theorem or LL theorem. Third, we have hypotenuse leg theorem or HL theorem or can also be HYL theorem. And the last, hypotenuse acute angle congruence theorem or can be written as HA theorem or HYA theorem. So if you notice, the names of the theorems are already the clues when to use these theorems. We will now try to apply this in proving statements on triangle congruence. Let's have this figure. Given segment PQ and segment RS are perpendicular to segment QR, and T is the midpoint of segment QR. So we have to prove the triangle PQT is congruent to triangle SRT. So we have here the two-column proof. Number 1, we have there segment PQ and segment RS are both perpendicular to segment QR. That is given. Now, since they are perpendicular, from its definition, we can say that angle Q and angle R are right angles. So our reason there is definition of perpendicular lines. Now, since they are both right angles, we can conclude in number 3 statement that angle Q is congruent to angle R because the reason there, all right angles are congruent. We have number 4. We notice angle RTS is congruent to angle QTP because these two angles are vertical angles. And from the theorem, it was stated there that vertical angles are congruent. So that's why our reason is vertical angle theorem. Then we have T is the midpoint of segment QR. That's given. Now, since T is the midpoint, we can conclude that segment QT is congruent to segment RT. We got that concept from the definition of midpoint. Now, since we have there two right triangles and the two legs plus the two acute angles are congruent, so we can conclude the triangle PQT is congruent to triangle SRT by LA congruence theorem. Let's have the second figure, triangle ABC. Now given, segment CD is perpendicular to segment AB, and D is the midpoint of segment AB. So we have to prove the triangle ACD is congruent to triangle BCD. So I have there the two-column proof. For statement number 1, segment CD and segment AB are perpendicular. That's given. Now, since they are perpendicular, we can say that angle ADC and angle BDC are right angles. Our reason, definition of perpendicular lines. Now, since they are both right angles, we can conclude in number 3 that angle ADC and angle BDC are congruent. Our reason there, all right angles are congruent. Then we go to the second given. D is the midpoint of segment AB. Now from the definition of midpoint, it divides the segment into two congruent parts. So we can say that segment AD is congruent to segment BD. That's definition of midpoint. Now we have there a common side on both triangles, that's segment CD. So we can conclude there that segment CD is congruent to segment CD. That's a reflexive property of equality. Now if you notice the figure, we put markings on both legs of the right triangle. So therefore, these two triangles, triangle ACD and triangle BCD, are congruent by LL congruence theorem. This time, we will be solving the unknown parts of the right triangle. We have there given triangle TWO is congruent to triangle SNE. Segment TW is perpendicular to segment WO, and segment SN is also perpendicular to segment EN. Now, this concept gives us an idea that angle W and angle N are both right angles and are congruent. Another given, measure angle T is equal to 35 degrees and the length of segment EN is equal to 12 cm. Now, since the two triangles are congruent, we can conclude that segment WO is congruent to segment NE, segment WT is congruent to segment NS, segment TO is congruent to segment SE, and then angle O is congruent to angle E, and angle T is congruent to angle S. So we have to find measure angle E and the length of segment OW. Now since angle E and angle O are congruent, so we have to solve first for the measure of O for us to solve for measure of angle E. So to solve for measure angle E, we have to add the three interior angles of triangle TWO. We have there measure angle O plus measure angle W plus measure angle T. That's equal to 180 degrees. Then we substitute the value. Measure angle O plus 90 plus 35 equals 180. Then we add the two numbers. So measure angle O plus 125, that's equal to 180. Then by subtraction property of equality, we have there measure angle O is equal to 180 minus 125. Then we have to subtract them. So therefore, the measure of angle O is equal to 55. Now since measure angle E is equal to the measure of angle O, we can conclude that measure angle E is equal to 55. Then let's solve now the length of segment OW. To solve for segment OW, since OW is equal to EN, I am referring to their length, we can conclude that the length of segment OW is also equal to 12 cm, since from the given, the length of segment EN is also 12 cm. I hope everything is clear to you. Thank you for listening and continue learning. Once again, this is Bunyasa Kappa, your math teacher.